All right, I've just had this great question. This is from the NCEA, here we are, NCEA Year 12. That's the end of year NCEA2 exam, and it's the calculus final exam for the year 12. So we've got a question here. It says derivative of a function is given by f prime x is equal to negative 3x squared plus 12. So negative, of course, is going to be a negative graph. And this is the integral, sorry, this is the differential. And if you differentiate something and end up with a squared, in other words, you end up with a quadratic, which is what this is, it must have started as an x to the 3. So it's going to be some kind of a cubic. And I notice it goes a negative there, so it's going to look a bit like this. It's going to come down and head up like that. So it's going to be something like that, yeah? And it says the graph of the local minimum is 0, 5. So the x value here, that is our 0 point. But it's also 5 up, so I'm going to have to draw it like this, yeah? So there's my 0 point. And this point here is 0, 5. There it is. All right. It says use calculus to find the value of the local maximum. The local maximum, of course, is this thing here. And you don't notice the term local maximum. We're not worried about that. It just means the maximum for that particular graph, yeah? As far as we're concerned, at least. All right, so there it is. We've got our y-axis, got our x-axis, and that's roughly how it's going to look, and it's going to have arrows on either end like that. Okay, so there is our cubic. It's going to look something like that, but we're going to find this point here. Now it says, use calculus to find the value of the local maximum. Well, here we're kind of in luck. This is a nice straightforward one to do. We're already given the gradient function, and we know if we make the gradient function equal to 0, we're going to find the maximum or the minimum. And the reason for that is because this point here has a gradient of 0. This point here has a gradient of 0. So m is equal to 0 at those points. M equals 0 at this point here. So we can go ahead and do that nice and easily, in fact. So let's go ahead and do that now. So we're going to make this equal to 0. So I've got f dash x, or if you like, f prime x, is equal to negative 3x squared plus 12x. I'm going to make this equal to 0. Now, if I make it equal to 0, it's going to give me both the minimum and the maximum at the same time, because it will give me two different possible solutions. So here it is. I've got negative 3x squared plus 12x. And I'm going to go ahead and actually factorize that. But before I do, I notice I've got a negative here. And it's just a pain. I'm actually not going to deal with a negative. So I'm going to multiply all of this by negative 1. All of this by negative 1. All of this by negative 1. Negative 1 times 0 is still 0. Negative 1 times this is going to be 3x squared. And this is going to be negative 1 times positive 12 is negative 12x. So now I'm going to go ahead and factorize. And by factorizing, I'm going to find out the values of these things. So this is equal to, I'll put a 0 equal. I'm going to have, what's common to both of these? Well, 3x is common to both. And I'm going to have, what am I going to have here? Well, 3x times x is 3x squared. 3x times 4, negative 4, is equal to negative 12x. So we could say either x must be equal to 0, because either that's 0 or that's 0, if this is going to be true, or x equals 4. So they're the two possibilities. And notice here we actually have, there's my x is 0, so x has to be 4. So this value over here, the x must be value of 4. So that's what we've just found. So we've got both, remember, the maximum and the minimum. The only difference, by the way, to find those is if we found the second differential, we would be able to determine algebraically which was a maximum or minimum by inserting the values in here into the second differential. And if it came out positive, then it would be a minimum. If it came out negative, it would be a maximum. But we're not asked to do that. We're not concerned with that. We're just concerned with finding the coordinate of this point here. Now, to find the coordinates, what we need to do is we need to get back to the original equation, because we don't want really the gradient function. We only needed the gradient function to find these points here. What we want is to use the original equation. So let's find that now. So right now we've got we want to find f of x, and f of x, as it happens, is going to equal the integral of, in this case, negative 3x squared plus 12x. And I'll put dx on the end. That's what we're wanting to do. All right, so let's go ahead, and we're going to say minus 3x, increase the power by 1, divide by the new power, plus 12x, increase the power by 1, divide by the new power, plus c. Now, there is what f of x is. Now, we also know, if that's f of x, we know that we've got a couple of points here. If x is 0, y must be 5. X is 0, y is 5. So let's go and put that in now. X is 0, so f of 0. Whoops, actually, I'm going to just change that slightly. Where's my kind of rubber here? Here we go. So I know f of x. Well, f of x in this case, and I'm going to just call this x and y. Yeah. Here's my y value. That's going to be 5. So 5 is equal to, and I'm going to make all these x's 0, which is going to be 0 plus 0 plus, what will this have to be? This would have to be 5. So therefore, c equals 5. So now we can write out the actual equation. Here it is. So we've got y, or actually I can keep it as f of x, although it really doesn't make any difference. But we should be consistent with the format, I think. So f of x is equal to, and we've got negative 3x cubed. Oh, and let's tidy this up as we go. 3 goes into 3 one time, so it's going to be negative x cubed. So I'm actually going to just make this a little bit more tidy. So it's going to be negative x cubed. There it is. What's this one here? 6 goes into 2. That's going to be 6 times. 12 divided by 2 goes 6 times. So I'm going to have plus 6x squared plus 5. And that's what we've got. Now we're going to make this f of, 4. We know it's 4, so let's plonk the 4 into the value for x. So f of 4 is equal to negative 4. Oh, no, it's positive 4, but it's negative outside, because negative outside. And that's going to be cubed plus 6 times 4. I'll put in brackets, there we are, plus 5. All right, what do we got? 4 cubed, that's going to be negative 64 plus 16. 16's a 96 plus 5. What have we got? 64 minus 96 plus 5 is going to be 37. So in this case, f of 4 is equal to 37. So therefore, we can say coordinate of maximum point is at 4, 37. And that would be my answer.